housekeeping rules. So this webinar would last for about 1 hour and we would conclude around 4 p.m. Indian Standard Time. I would request all the panelists to keep their microphones and cameras on mute and cameras switched off during the session when they are not speaking. Only the speaker who is giving the session would be keeping his microphones and cameras on. We also have a chat option which is there on the down ribbon on your screen. In case you have any concerns about your settings, audio, video issues are there, please let us know through the chat options. Do not include any questions related to the technical discussion in this session in the chat option. For that, you have another tab there, which is called as the Q&A section. Any questions related to the content, any queries you have, please put up in the Q&A section. At the end, we will also have a live session, question and answer part, wherein you would be allowed to speak live and the speaker will take up your questions. There is an option to raise your hand, and with that you can let us know in case you have any questions. There is also a poll at the end. Please rate the quality of the poll at the end of the session. And we would also be live streaming the session. Please let us, we'll share the link shortly in the chat section. So with that, I would hand over now to Mr. Captain Roy Joseph, to introduce the speaker of today, Captain Roy Joseph.
Welcome, ladies and gentlemen. I am Captain Roy Joseph from Ministry of Defence, Department of Defence Production. I welcome you to the second webinar in the series of webinars we are organizing in the run-up to Aero India 2019. Aero India 2019, the premier aerospace event, the largest air show in Asia, is being organized in the beautiful city of Bengaluru from 20th to 24th Feb 2019. Now coming to today's webinar, Mr. Jitendra Yadav, Director, National Aerospace Laboratories, on behalf of the Indian National Academy of Engineering, giving us an insight on the regional transport aircraft of India. Mr. Yadav is an electronic engineer by education and has done his master's in computer engineering from the Defence Institute of Advanced Technology, Pune. He has more than 29 years of experience in design and development of military systems, besides providing solutions for industry and railway applications. He has designed, developed, and commercialized major systems like fire control systems for tanks, airborne digital optronic pedestals for Nishan UAV, optical fire control system for Navy, mission and display computer and weapon control system for the light combat aircraft, Tejas, tactical mission systems for helicopter, and digital servo systems for automobiles and railways. Prior to taking over as Director of National Aerospace Laboratory, Mr. Yadav was the project director of flagship project of LCA, the Light Combat Aircraft project. He was instrumental in steering the initial operation clearance and also the induction of these aircraft into the armed forces. Under his leadership, the National Aerospace Laboratory is making important contribution towards furthering Make in India in aviation sector, both in the military as well as in the civil space. The maiden flight of Saras aircraft is a testimony to this. A recipient of many awards and laurels as part of his work in DRDO, in Aeronautical Development Agency, in National Aerospace Laboratory. He has also published more than 20 papers in national and international journals of repute. He will be speaking to us today on the indigenous solutions to regional air connectivity. We all know that passenger traffic is growing fast in the Asia-Pacific region, especially in India. India by 2020 is likely to handle third largest passenger air traffic of the world. The demand for regional air connectivity is also increasing due to new aviation policy and the UDAN programs. Mr. Jadhav will give us an insight into what is in store in this exciting space, including the use of green technologies. May I now request Jitendra Jadhav, Director, National Aerospace Laboratory, to commence the proceedings. He will be speaking to us from his headquarters in Bangalore. Over to you, sir.
Thank you, Captain, for a nice introduction of mine and insight of the Indian aerospace programs. So I will be covering in my presentation what is the brief given by Captain Joseph. And slides, please. Yeah. So today's my topic is regional transport aircraft for Indian scenario. Next slide. If you see the today's government policy, there is a major thrust given to the new civil aviation policy, and it has been more on to the promoting the regional air connectivity. If you see the right side of my slide, India being a cluster, if you take 4 clusters, Western cluster, South cluster, North cluster, and Eastern cluster, we have got heavily populated cities at a distance of about 200 to 500 kilometer. Okay, and to connect these cities, there is a today need to build a regional transport aircraft where the people can travel from cities to the major towns for education, employment, medical, trade, industry, and business. The forecast which has been projected is about 300 million passengers by 2022 and 500 million passengers by 2027. So next slide. The Government of India has started a new civil aviation policy in 2016 called UDAN. The full form is Ude Desh Ka Aam Nagrik by Ministry of Civil Aviation. It is basically to promote the air connectivity between the Tier 2 and Tier 3 cities. So far, about 128 routes are already awarded in first round of bidding, and 325 routes are also awarded in the second round of bidding. There is a plan to upgrade about 35 airports at already 35 has been upgraded, and about 100 airports are getting upgraded at the cost of rupees 17,500, and hence there is a significant demand for regional aircraft. Next. If you see the existing regional aircraft scenario for connecting the cities which are less than 500 kilometers, there are only 2 players today. One is Bombardier from Canada and ATR from Europe. But these are all the technologies which are available in aircraft, especially airframe and engines, are almost 2 to 2.5 decades old. And they are costly today at this present scenario to acquire. The operation cost is very high, and it needs very well equipped airfields. Also, the consumption of the fuel and the emission levels are also very high. And in general, the operator is facing high maintenance operation and the noise levels also. So these are the basic shortcomings. I also taken Russian IL-114 also for comparison. So these are the shortcomings of the existing aircrafts available in the world. Next. So we have worked out that today we had a discussion with Indian operators regarding their needs and demand. And what they are looking for is there should be about 25% reduction in ownership cost, 15 to 20% reduction in fuel burn. Aircraft should have ability to land in any ill-equipped airfields. Maintenance cost should be lower, and aircraft should be environmentally friendly. And more important is more cabin baggage space, because if you see the existing aircrafts, the baggage space available is very small. So we did a market survey. What is the potential requirement in South Asia and India? So there are about 260 civil passenger aircrafts and about 46 freight cargo aircrafts required in next 20 years in South Asia as well as Indian territory together. And worldwide there is a demand of about 3020 passenger aircrafts and 460 freight aircrafts. It shows also it corollaries with the recent planned acquisition by Indigo about 50 turboprop based aircraft from ATR and 50 turboprop based aircraft from Bombardier by SpiceJet. Next. So we are proposing a next generation regional transport aircraft where basically the power plant will be with a new generation turboprop engine which can have a low fuel consumption and 50% reduction in maintenance cost. Also, we are planning a state-of-art glass cockpit and the flight control system where we could able to achieve the targeted operating cost, acquisition cost, consumption and maintenance cost. The figures are there, I don't have to read. And this aircraft will have unique facility to take off and land from unequipped airfield, all weather operations. Their emissions will be lower by 70% and it will have advanced facility. CSRNL has done a feasibility study of such aircraft and we have already completed these studies and the report has been submitted to the Government of India. Next. So the broad requirements of this aircraft will be, it will have a range of about 2000 kilometers. It will have a speed of about 600 kmph max. Fuel consumption will be less than 20% with the contemporary aircrafts, and all other thing it will have ability to operate from ill-equipped non-frill airports. If you see the right side, there is a cabin layout for 4 abreast configuration, and there will be three versions which has been planned: 50, 70 and 90 seater. So this is what now there is essential for the country to take up the development of this aircraft. Next. So we are planning to meet this requirement by putting a world-class technologies with the first with the natural laminar flow wing, a next generation power plant, a fly-by-wire control system and display system. The avionics will be open distributed avionics. There will be a GPS, ESVS, ADS and active vibration control system. From the maintenance point of view, there will be integrated vehicle health management system, including faster troubleshooting mechanism. Aircraft will have more electric and mechanical system. A lean ground infrastructure will be the major thing to make the aircraft. And aircraft will have advanced materials and self-clean coatings and also the composite airframe and including structural electronics. So these are the technologies which will go into this aircraft. Next. So how these technologies will make effect to the cost of the aircraft is this slide showing that the aircraft cost is reduced due to the low cost composites in the airframe and lower cost of operational cost of the engine. Also the integrated open architecture system and the fly-by-wire control system. The maintenance cost is reduced by the powerful IVHM, structural health monitoring and the health monitoring of the next generation engine. The Fuel burn is also reduced by fly-by-wire and many aerodynamic fixes with laminar flow control and all, and more effective. This also the noise is being reduced by highlight devices and uh, beyond stage 4 engine, and also takeoff and landing aids are been acquired through various GPS based navigation system and the synthetic vision and ADSB and situational awareness system. So these are the various technologies which we discussed in previous slide will have been consolidated how we can achieve the targeted low cost green regional aircraft. Next. So I will just tell you the core competence available in the country today. Next. So in our country, we have a very good group in aerospace, material science and surface engineering. We are very strong in structural engineering and testing. We have a very strong group at the national level for fly-by-wire flight control systems, which we developed for the light combat aircraft. Also, we have a very good group in the avionics and digital computers, digital systems, which as indigenously developed for the light combat aircraft and ALH programs, also for the satellite programs. We have a good group into the turbo machinery and controls, and also the electromagnetics and other things. So this is the gambit at various organizations in Government of India, where Hindustan Aeronautics, also ISRO, DRDO, and CSR being together have various expertise available in this field. Next. We have recently revived our 19-seater aircraft, Saras. Just you can run the video. The video is running at the right side. So this Saras aircraft we have revived and we call it as prototype 1, which has been flown in January 18. And this will be used for 19 pax passenger aircraft as well as for troop transport, cargo transport, executive transport, and also for the evacuation and surveillance also. This aircraft will have a weight about 7.1 ton and it has got a speed about 550 kmph and the range will be around 500 km and its specific fuel consumption will be around 1.5 km per kg. It will be far superior and it will have a pressurized cabin, that is most important. It will also have a capability to operate from ill-equipped airfield. So this will be far better than the contemporary aircraft which has been compared at the right side of my slide. Next. This aircraft will be in production by 2022. We also developed two-seater Hansa next generation aircraft.
NAL invites you to witness the flight of the Hansa.
Okay. So this two-seater Hansa is basically for flying training and it will have a glass cockpit. Already 14-15 numbers of aircrafts are already inducted, but there is a requirement of changing to the glass cockpit for the commercial pilot licensing. So we have taken up this project and this will be in production from 2020 and the private partner has been identified as a risk sharing basis. Next. We have a good aerospace technology base for the development of technologies. More than 100 work centers has been worked for the various programs in the country like light combat aircraft, ALH Dhruva, intermediate jet trainer and Saras. We have a skill set and faculties. We have a design and certification know-how. And we have a precision manufacturing base, like from the small, medium scale industries to the large private and public sector industries. So the ecosystem required for the development as well as manufacturing has been well established in the country with the programs like light combat aircraft, ALH and intermediate jet trainer and also certain amount of program like Saras. So the experience of these aircraft programs including the test facilities and the production manufacturing base, will be useful to make this aircraft in the country at a lesser cost. Next. We have a plan of this program is we already completed the feasibility study and we will be taking up the project definition phase in next 18 months. After project definition phase, we will be taking detailed design development and prototyping phase for next 40 months. And then the flight test and certification will take 70 months. So right from today, about 5 years time, the aircraft will be starting the production phase and it will be inducted to the services. So this is the plan of execution. Next. Thank you very much for the patient hearing. Now I am open for the questions.
Thank you, Yadav, for such an informative and educative session. I'm sure all the participants have enjoyed this session. Now it's time for the Q&A session and we will take some questions live. Please raise your hands. Mr. Rath, I am allowing you to talk. Please put up your introduction and then ask your question. Mr. Rath, you can speak now.
Hello. Yeah, can you hear me?
Yes. Please.
Yeah, good afternoon, sir. Thank you very much for the lovely presentation. It gives us a very good insight about RTA, which we've been thinking about quite a long now. And it's seen some light once you've taken up. So I work for a company called LGM Group, which is a Paris-based company. And we specialize on integrated logistics support studies and maintenance engineering. So when we saw the presentation, there was a clear definition on the design phase and on the production phase. But could you just help me with the strategy that we have for the maintenance of these aircraft? Because like you said in the previous slides, there is the aircraft carriers generally ask for a lower maintenance cost over the period of time. So any light into the maintenance strategy that we follow for these programs, it would be really great.
Yeah. So thank you for a question. So basically what we are planning in this aircraft is a complete digital avionics and digital flight control system and also the next generation turboprop engine. So the whole vehicle health management system, which is additional system which is the part of this digital avionics, flight control and the propulsion system, will be running into the central computer. We call it as flight management computer, where this particular health management of airframe, also the subsystems like avionics, flight control, and also the propulsion are all monitored together. Then there will be a diagnostic and prognostics algorithms will be running into that computer based on our analysis data as well as FMSA. You may be aware of these terminologies, and fault tree analysis which was done into the design stage.
Yes.
And then there will be algorithms for this will be running onto the computer, which will make this aircraft more maintenance, less prone, means less cost of maintenance. That is what we are worried. So in summarize, what I would like to answer your question is a good integrated engine health management system, a good integrated avionics and flight control, good integrated structural health monitoring system, and integrating these systems together at a central computer and running prognostic diagnostic algorithm, we will achieve this.
I hope, Mr. Rath, that has answered your question. Mr. Srinivas Kirti, I'll take your question as well. Please speak.
Hello, sir. Are you able to hear me?
Hello?
Hello, sir. Are you able to hear me?
Yes.
Yeah.
Go ahead.
Thank you very much for your presentation. I'm a PhD student at the Aerospace Department, Indian Institute of Science. So you mentioned lowering of specific fuel consumption, the SFC. Could you please tell me what all key technologies are being brought out or being thought about to achieve that? Thank you.
See, there are two ways of lowering the specific fuel consumption. There is a aerodynamic drag reduction is required. And if you see the technologies which I put laminar airflow type wing. Okay. And also a lot of aerodynamic fixes has been done in aircraft to reduce the aerodynamic drag and improve the L by D ratio. That is one part to reduce the SFC. Second one is the engine itself is a next generation technology where the compressor and turbines and all these things has been optimized by the electronic control, which also will give us the next this thing. Then coming to the composite wings and weight, because the complete aircraft weight has been optimized by using the composites at the larger extent, so that the whole L by D and T by W, they are all together. I feel you are a PhD student, so weight is reduced, so L by D and T by W will get the advantage. So that has been taken care. And another fourth important thing is the flight control and avionics, which will together make some more advantage of that. So we did a breakup that with what percentage this will contribute. So each fellow contributes 3%, 4% and all, and like that we are planning to go for 15% reduction fuel consumption.
So I hope that answered your question. Next, I'll take Mr. Saurav Jha. I'll allow you to talk. Please give your introduction and then the question. Mr. Saurav Jha, can you hear us? Hello? Mr. Saurav Jha?
For the next man.
Okay, I will take Mr. Nijesh.
Hello, I'm here. Hello.
Okay, Mr. Saurabh, please go ahead.
Yes, I missed the earlier part of the presentation. I'm the editor-in-chief of Delhi Defense Review. The question I have is related to the advanced turboprop engine. Given that we haven't succeeded in developing engines per se, even whether it be whether it be gas turbines or it be even Wankel rotary engines, we are still not mass producing them. How confident are you about obtaining this engine, this advanced turboprop engine, in the next 70 months?
Yeah. So I will just first clarify your doubt about Wankel engine, because Wankel engine, maybe the requirement may not be more, but CSIRNL has made a Wankel engine up to 65 HP and it is certified and it is flying in the DRDO program of Nishant and Panchi and all. So that is about the disorder. About the gas turbine engine, I understand that there are a lot of challenges and all. And so the challenges are also exist in this turboprop engine. So we are looking for an international partner and we are discussing with the international company. Okay, like few companies like General Electric and Pratt and Whitney, and they are already having a drawing ready, and they have also done a component testing at their laboratory to see that this engine is available. It is a matter of integration of these components and get it certificate. So the OEM has already told that he can able to do it within 3 years time if the go ahead has been given. And definitely we are not going to planning to develop this indigenously as on today. So it is with the international partner, and already he is having a design and testing done for the component level. So I don't find any problem in getting this engine within the time which we have mentioned.
Thank you, Jitendra sir. Let me know if you want to take more questions. If we have the time.
I can take one more question.
Okay. Mr. Dilip Kumar, I'll allow you to talk.
Yeah.
Hi, I'm Dilip Kumar from SFO Technologies, Cochin. My question is about the structural health monitoring. So what kind of solution we are planning? Is that going to be indigenous, or are we going to take a package solution from an OEM?
See, structural health monitoring, we are having an indigenous fiber bracketing sensors, which has been used in our UAV programs and which needs certain amount of higher qualification that will be used. And then also the metal strain gauges, which are required where fiber bracketing sensors will be spread over the wing or on flat surfaces basically. And wherever the T-type surfaces or connecting surfaces are there, there will be the metal strain gauges are used, and rest all few vibration sensors and accelerometers will be put at the various places where there are load bearing things. So these are all is the indigenously available technology which we have already proven for our existing UAV programs, and that same will go, including sensor has been done at our CGCRA laboratory at Calcutta, and that sensors has been qualified now, fiber bracketing sensors. So I don't think we should go for any imported technology, and this will be totally done indigenously. Also, there is a group has been formed to work on prognostic diagnostic algorithms also, and they are also given a good results about SHN for the UAVs of 100 kg class. So the technology is already available.
And what about the glass cockpit?
Glass cockpit is we are masters actually. If you go to our LCA, the total LCA is a glass cockpit. So glass cockpit, I think we can sell the technology to the foreigners.
Thank you, sir. Thank you so much for your information. Now I will transfer to Captain Roy Joseph for some words.
Thank you, Mr. Jadhav, for the most enriching insight into the development of regional transport aircraft and about the future plans of NAL. I also take this opportunity to thank Digital India, NEDB, Hindustan Aeronautics Limited, National Aerospace Laboratories for organizing the webinar today. A special thanks to all the participants who have joined us today. Thank you, ladies and gentlemen.
Thank you.
Thank you, Captain Roy Joseph. Now we'll put up the screen for the next webinars. So now you see we have our next schedule of webinars. The scheduled webinar would be on 2nd January 2019, 3 p.m. Indian Standard Time. I would request all the participants to please spread the news and please share this with others, your colleagues, your friends. You can give the link to the website and ask them to join for this webinar. Now I will transfer to Mr. Shilo Rao, GM Capacity Building NEGD.
Thank you, speakers, for giving a wonderful session. And if you don't mind, there is one interesting question I noticed. If you permit, we will allow the gentleman to raise this question. I found it is very relevant to the topic. If you permit, can we allow only one person? Is Mr. Prajwal Shiv Prakash from German Aerospace Industry. He wanted to pose a question to you. I think Prajwal, you are live, I guess. Shall we allow you?
Yes, yes. I have no objection.
Okay, sir. Then I will just allow him. Only one person, Prajwal. Mr. Prajwal, I enabled you. Please, please raise your question. Okay, Mr. Prajwal, you are out there. Okay, Mr. Prajwal, there is some issue with respect to your software. I could see some issue, but I will read out your question to the speaker so he will able to. Sir, I'm just going to read out. This is Prajwal from German Aerospace Center, Germany. It is a good and important project to bring in all the engineering and research knowledge in the country. It will also has technical snowball effects in US. It was NASA, Apollo mission, Brazil, it was Embraer. I hope triple P model of civil aircraft development will achieve this in India. Secondly, what is the strategy for certification and certification risk? International collaboration also opens up the market with international partner as well. He himself said he don't have an audio and video. This is a question he posed, sir. I've taken a liberty, Mr. Prajwal. I hope you are happy with that. So this is the question, sir.
Yeah. So I can understand the question is what is the strategy for certification we adopted? Okay, that is the main question looks to be. So today definitely we need international certification for this aircraft, and even though today Directorate General of Civil Aviation is fully geared up, so we will get that certification for flying in the country. But since we are looking for a total global market, we will also plan to have it is certified for FAA. So for that, we are looking for an international partner for FAA certification, which will be identified during our project definition phase. The aircraft can be certified for FAA, it can be certified for ESA, it can be certified for CASA, all that, because they are all having the back-to-back arrangement. And there are plans to get it certified with the international partner for FAA. That's all I can answer about this question. I didn't understand the second question about international collaboration. Okay, definitely this project, which we have some gaps in the technology, we will collaborate with international partner. That is in our mind. But all these things will be more visualized in the project definition phase.
Thank you very much, sir. I just wonderful. I was also very much enlightened with your knowledge and advancements in the aircraft from our country. We are very proud to have you today. In order to just spice up the today's session, I'm just going to share the theme video of Aero India for the benefit of our attendees. Thank you very much. I hope you liked the video, and it was a wonderful video made, Billion Opportunities as a Runway. And I also would like to share the live portal for Aero India for the attendees. I just now I'm sharing this. This is the live portal. All information related to Aero India 2019, a runway to billion opportunities, is available here. About the event schedule, different type of seminars have been there. All relevant informations are available. I request the attendees, please take note of the website, and this website contains all other options. Even students can have students pavilion, concept node is there, and we have kept this webinar link registration is also available in this portal. You can register here by clicking here. You can key in your details and register so that we can keep post to you about the new webinars which is going to take place. And there is an option to join webinars which are already listed. Already 2 webinars are listed, so you can able to see the time, date, the click with the profile of the person who's taking the session, and also the link to join the webinars is also been given. And you can see the tentative schedules already there. 2nd Jan we have we have one more session with Dr. Amitabh Saraf, who is an outstanding scientist. And also we have 10th Jan, we have Dr. Balamurugan from HAL is going to be part of the one more webinar from our side. And now I this is a collaborative effort from Defense Ministry, Department of Defense Production, and Hindustan Aeronautics Limited. We are very happy with Hindustan Aeronautics Limited, led by a team, Shri Prakash, he is the General Manager, Mission and Combat System, along with Sunil and his team. Thank you very much for giving us an opportunity to work with you. And this is it. I'll just sign off from here. I hope my colleague Bhumika, you have anything to share, please carry on.
Thank you, Shilok sir. Indeed, it was a very, very proud moment for us to share this opportunity with Aero India. NEGD is very thankful for being part of Aero India 2019. And this is the first time these such webinars are being conducted to disseminate knowledge. And we would request again the participants who are here today to spread this news and share the knowledge with everyone. Before I end, I would just like to thank my CEO, Mr. M.S. Rao, President and Chief Executive Officer, National E-Governance Division, Dr. Ajay Kumar, Secretary Defense Production, Shri Varun Mitra, Additional Secretary Defense Production, Shri Vijendra, JSNS, and the team from HAL, Mr. Sunil, the team from NAL, Mr. Venu and his team, Captain Roy Joseph, and also we will. I would like to thank all the team members of LMS Digital India here at NGD for giving such an successful session. Thank you, everyone. With this, I conclude, and I wish you a very happy New Year, a Merry Christmas. May we all prosper, and our country continues to rise and shine in the next year. Happy New Year. Enjoy.
Thank you very much, madam.
Thank you. Thank you.
Thank you. Thank you.
We're closing.